Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, James Engineering Management Technical Campus, Knowledge Park 3rd, Greater Noida. The subject that I teach in this semester for BTech 5th semester students, OBC branch, is digital communication, and the topic that I discussed today is CDF and joint CDF. CDF means cumulative density function and joint cumulative density function. See, the cumulative density function CDF, in short we say CDF, denoted by Fx. Look at this particular F symbol, F. This should be capital F, not small f. If you write a small f instead of capital, then it becomes probability density function, PDF. So to denote CDF, you should write capital F. So this is capital Fx means F means cumulative density function of what? Of capital X. X is any random variable. So if you have any random variable and if you want to denote its cumulative density function, then you have to write capital X in bracket, write capital X. So this capital X is a random variable who takes any value of small x, and Fx become cumulative density function of that random variable capital X. And it measures the probability that the function variable x assumes a value less than or equal to x. This is very important because to obtain cumulative density function, your last limit is small x. For example, if you play Ludo, you can say that the outcome is random, but you know the last limit. The last limit is 6. You can't get 7, 8 or 9. You always have a maximum value of 6, right? So there is always a upper limit and there is no lower limit in cumulative density function. So mathematically, how we denote, how we write? We write Fx, capital Fx is equals to probability that x is less than or equal to small x, where small x have any value which is maximum. So we always have a upper limit, but we don't have a lower limit. So that could be goes to minus infinity, right? So the limit generally in cumulative density function is minus infinity to x. So we always have a upper limit. We don't have a lower limit, and that's why we write in this way. So if x, capital X is a continuous random variable with density function small f, that cumulative density function is denoted by that manner. Cumulative density of x of small x is equal to probability of x, capital X less than or equal to small x, where x is a maximum value. So we can write minus infinity to x of ft dt. So this is the way that we write cumulative density function Fx. So what is this Fx? Fx is the area under the density function ft from minus infinity to x. This is the difference. So there is a little bit difference if you compare cumulative density function with probability density function. Yeah, right. So in cumulative density function, we always have a limit minus infinity to x. And basically the concept remains the same. As far as cumulative density function is always tells you to how the probability is distributed over the area, and CDF also do the same. So CDF, PDF basically as far as the concept is concerned, concept remains the same. The only difference comes to be a upper limit. For example, if you have a limit a is less than b, then we can write probability of a less than or equal to x less than or equal to b. So b is the upper limit and a is the lower limit. So what you have to do, you have to just integrate between a and b ft dt. And what you have to write with this particular integral, you can break this integral in this manner, So that comes to FB or FA because of the formula minus infinity to V ft dt. It's actually the cumulative distributive function of small b. Minus infinity to a ft dt, this is actually the cumulative distribution of small a. So that is one of the mathematical expression you can write down in that way also. Properties of CDF. F is a non-decreasing function. If a less than b, then fa less than equal to fb. Look at this first property. If variable a is less than b, then its cumulative distribution function is always less than or equal to cumulative. If a is less than b, then cumulative distribution function of a is always less than or equal to cumulative distribution function of b. This is your first statement. Second statement, third are very important. As far as the limit is concerned, if your limit of x is greater than minus infinity, then its cumulative density function should be 0. And if the limit is greater than infinity, then cumulative distributive function of that in that case is 1. So basically these three properties are very important as far as CDF is concerned. Then come to joint cumulative distribution function. We already have joint PDF probability density function. In similar way, we have a joint cumulative distribution function. Here the two random variables are involved, capital X and capital Y. Capital X have any value of small x, capital Y have any value of y. But there is a limit again. The limit as far as capital X is concerned is minus infinity to small x, and as far as the y is concerned, it is minus infinity to y. Yeah, right? So this is the only difference. So if for example, if the limit of x is minus infinity to a and limit of y is minus infinity to b, then we can write cumulative distributive function FAB. Look at this FAB. Cumulative distribution of FAB is equals to probability density function, and we integrate by putting the limit minus infinity to b for y and minus infinity to a for x. So the only difference as compared to PDF is the limit, right? It is always have a limit of minus infinity to a certain maximum value of a random variable, right? So FAB is to write down in that manner. So this is all about joint CDF of x and y. Then as you know that basically the relation between PDF and CDF is that if you take the derivative of CDF, you will get the PDF. So this particular concept is also true in the case of joint. Means joint PDF comes if you take the derivative of joint CDF. That's why this particular statement FAB is a probability density function AB. It is the derivative of cumulative density function AB. So basic concept remains the same. What is basic concept? PDF always be the derivative of CDF. And this is also true in the joint case, whether joint PDF or joint CDF. So thank you. So in this particular lecture, we focused on joint CDF and its some properties, right? But if you compare CDF with PDF, PDF is more important than CDF because most of the questions are coming in examination based on this PDF or joint PDF rather than CDF. But one or two times this CDF also be asked in previous examination. So students, I just say you that you have to prepare PDF, joint PDF and CDF and joint CDF with equal efforts, because question may be asked, and that is I sure out of out of out of 10, 9 times numericals come in the examination based on PDF or CDF, if sometimes joint PDF or joint CDF. So please focus on that. Thank you very much.